Hudson Valley Passive House Alliance meeting. My name is Michelle Tinner. I'm the chapter president. Honored to be serving my second term as of September. And today we actually have record registration for this Zoom meeting, which is amazing. We have close to 100, so 98 people registered. That's the most we've ever had, and it's such a rewarding progress for our chapter to see. And also, I'm sure, a testament to our excellent lineup of presenters this evening. So I don't want to take up too much time with introductions because we have a very packed schedule. Let's see. So before we get started, just a couple of housekeeping items and an introduction to our chapter for those of you who are joining us for the first time. Please keep yourself muted. We don't want any unnecessary feedback or any background noise. You can unmute yourself to ask questions during Q&A. You can also use the chat feature to ask questions throughout this meeting, and some of us will be monitoring that feed. And if you're willing, please share your camera. Let us see your face. It just adds to that sense of connection in our virtual reality these days. So the mission of our chapter is to contribute positively to a low carbon future through education, training, and advocacy for the Passive House standard, and to make it the mainstream standard of building for our future. We're inclusive of all professionals engaged in design and construction and testing of high performance buildings, regardless of the origin of their certification, and we value the contribution of each individual. So we strive to create a culture of collaboration. We share throughout our membership base and collectively contribute to the advancement of passive building methods through all of our work. So in addition to our quarterly meetings, we get involved in things like local conferences, advocating for the adoption of stretch code in our local communities, and also supporting passive house training efforts throughout the state. And so, none of this is possible without the support and participation of our wonderful membership base. And with that, I'd like to really, encourage all of you to consider becoming a member of this great alliance. Your participation is vital to the strength and effectiveness of our organization, and membership does provide you with the rights to vote, hold office, and earns you great discounts or free admission to Phius or Phius events, including informative webinars, attendance to the annual conference, and professional training courses. And the dues that you pay to be a member go to good advocacy and coursework development at the national level, but at the local level, the affiliate chapter that you select also receives a portion of that, and it enables the work that we do, putting on these types of events, tabling at different local conferences, and so on. So to become a member, you can go to Passive House, or to our website, which is pha-hv.org. I'm going to post that in the chat shortly. And we have a link there for membership. What's important is that you select the Hudson Valley chapter as your affiliate chapter, so that part of your dues do come to us. By all means, if there's a local chapter near you, I would encourage you to join them. It's very helpful to be able to get together in person as well with your groups. And so the agenda for tonight: first, we have Advancing Climate-Friendly Concrete in New York through State and Local Action. That's going to be presented by Chris Neidl from the Open Air Collective. Then we have Rethinking Assumptions, Building Without a Concrete Slab, which is so totally rad. Lillian Maurer is going to be presenting that from BuildingLogic. Then the Gallatin Passive House, More Cowbells, which, Stephanie, that's either a reference to like some Swiss product or like that Blue Oyster Cult, what's it called? Saturday Night Live skit from a million years ago.
The latter, yeah.
Oh, really? Amazing. I can't wait. All right. And then John Lorscher, who's the Northeast Regional Rep of Phius, is going to give us an update on what's in store for us with Phius 2021. And then at 5:30, we're going to move into breakout groups. And we have almost 100 people, or maybe close to that, today. So we have 6 breakout groups, and these are intended to be kind of a virtual networking session. You know, since we can't get together and have a beer and talk to each other face to face, we figured we'd try to create a kind of smaller, more intimate environment with these smaller groups for everyone to go around, introduce yourself, what you do, you know, how your work relates to Passive House, and then also to give the, you know, your moderator in that session feedback about our chapter, you know, topics that you'd like us to you know, maybe have a session on at an upcoming meeting, and so on. And then at well, 5:50, we're gonna join back together for final conclusions. So we can't assume that everyone is an expert at Passive House when they join these meetings. We encourage everyone to join. So as a primer for Passive House, we like to show this video. It's just a minute or 90 seconds. So here we go. Oh, how do I go back? Here we go.
Passive House explained in 90 seconds. Does your house have a heater in the basement or maybe a fireplace? Probably also a central air conditioner or maybe a window unit. Did you ever wonder if it was necessary? In 1991, a physicist in Austria, Dr. Feist, built the first passive house. Here's what he did. 1. Proper insulation. It's just like wearing the right winter jacket. It also doesn't need a heater. 2. No air leakages. There should be no holes, small or large, to let hot air out of the house. 3. No thermal bridges. A thermal bridge is like a road for heating energy in which warmth can travel right through your walls. As a matter of fact, most of our houses have thermal highways in our walls where heat can easily travel to the outside. Plus, the house needs proper windows most of the time with triple pane glass. It needs to be oriented properly so the sun can heat it in the winter and shade is provided in the summer. And it uses an HRV, a device that provides the inside with fresh air without letting the heat out. Add all these things up, and it turns out your house doesn't need a heater or air conditioner. So where does the heat come from? A passive house needs 90% less energy, and that can easily be supplied by your body heat, the sun, your appliances, light bulbs, and even your TV. This saves you a lot of money on your heating bill and helps preserve the environment. Did we make it in 90 seconds? That we did.
All right. So there you have it. That's Passive House. We typically have CEUs, Phius CEUs for these events. We didn't get our application for those in on time this round, so we will be sending the verification code out once we do have it. Apologies for that, but it will be distributed once we have it. Couple of upcoming events. There's AIA Westchester and Hudson Valley Sustainability Committee presentation number 3 happening next week on the 17th. We can share links to that on our social media for anyone who's interested. It'll be a deep dive into passive house air tightness. And then AIA Residential Architecture is going to have a session on practice focused on high performance builders on January 26th. And also, just to share with you, Phius just released their hootenannies that they had on YouTube. So anyone who's interested in checking those out, they're available. And then on the Phius member portal, there's several different, sessions and webinars that you can check out. And also Phius has started this new thing with office hours, which is really great and helpful. So kind of keep your eye on the Phius newsletters for more information on that. Okay, thank you. And here's all our kind of, website information, etc. And without further ado, I would like to hand this over to Chris for his presentation.
Great, thank you so much, Michelle. Really honored to be here. I'm gonna go ahead and share. Let me know when you can see it.
We can
Great,
see.
Is that visible? Perfect. Great, yeah, huge fan. I am gonna talk to you about concrete tonight. I don't come from a passive house background, but I come from a solar background for 15 years and have been lucky to intersect with the passive house community in Brooklyn and other places. And so really honored to be here and thanks for the opportunity. What I wanted to do is just give you a little bit of background on some efforts that are happening here in New York State, kind of spilling beyond New York State now, around really trying to advance low embodied carbon concrete, both at the state level and through local action through policy. And first, I'm one of the founding volunteer members of the Open Air Collective. And we're a 100% volunteer network. And I want to actually pause and just really quickly thank Seth Wiley for making this connection here and sort of bringing me into the fold of the Passive House. Seth is a sort of a tireless member of Open Air who keeps creating opportunities for our community, this being one of them. And Open Air is just a volunteer community of basically activists who are really interested in advancing negative emissions technologies. So there's no formal organization, no 501c3, just a bunch of people who more or less convene on Discord and plan actions and execute them. And the two areas of our work are both R&D and advocacy that we're really involved in right now. So to give you some flavor of the diversity of what we do, on R&D right now, our main project is what's called Violet. This is where we're trying to build a miniature open source direct air carbon capture machine, which pulls carbon directly out of the atmosphere, and we'll publish that under a free license on GitHub. But on the other side, the area that we've been most active in relates to the subject tonight, and that's on advocacy. To advance any new technology, it's only really as good as its sort of policy environment in which it sort of swims. And a key area that we've strategically chosen early on is concrete. And so we've created something called LECCLA, which is the Low Embodied Carbon Concrete Network, which is sort of focused on state and local level action to try to really drive adoption of low carbon concrete. So what I want to do real quickly, a lot of this will be more familiar to you. Again, I'm a solar guy, was until 18 months ago. So I'll just give a quick summary of why concrete matters to climate, and then talk about two levels of action that we're really trying to advance here in New York State. That's the Low Embodied Carbon Concrete Leadership Act, or LECCLA, which is a bill that we've introduced in Albany, both in the Assembly and the Senate, that would require the state to factor climate impact into its concrete procurement. And then I'll talk about some of the really exciting stuff that's happening at the lower level of local government leadership. And I'll talk about our collaboration with the Village of Hastings on Hudson in a new project called the Open Source Sidewalk Initiative that we're just about to push forward with. For folks here in the region, Hudson Valley will be definitely a real hotbed, but hopefully it'll be something that'll have a much broader geography. So again, just to sort of summarize, as you all know, concrete is obviously very relevant to climate. A lot of that is driven by the fact of just by how much we use. It's the second most used substance on Earth. It's hard to assess exactly how much is used, but upwards of 30 billion tons per year of concrete are produced, and that's only going to continue to increase as urbanization increases. But in addition to sort of the scale at which we use it, the ingredients really matter, and in particularly Portland cement. Portland cement is only about 10 to 15% of concrete. It's the main binder that kind of pulls together all these other abundant materials so that they have the magical sort of performance properties of concrete. But it's 15%, but 85 to 90% of all emissions are accounted for with cement, because it has an incredibly carbon intensive process by which its main ingredient, clinker, is made. And so when you think of the carbon intensity of the ingredient times the scale at which we use it, that means that about 7 to really upwards to 8 or 9% of total global emissions really trace back to cement. And the vast majority of cement is used in concrete. So when I think of concrete, I think of sort of two big ideas when we think about the future of it as it relates to climate. One is pretty obvious. It's the way we think about most high polluting sources of emissions, is that we have to reduce the embodied carbon, the carbon that is emitted in the making of that thing, for cement and therefore concrete. And cement, again, is the main piece here. But the other thing about concrete, it's really exciting, is that it has some additional properties as a whole material that can be carbon positive. And I know this is an idea that's obviously emerged in significance recently, and certainly is familiar to the Passive House community, with carbon positivity, which sometimes confusingly is called carbon negativity. But carbon positivity, is just the, sort of the outcome where by building things, you actually not only reduce harm to the environment, but you have a net good. You do something that actually improves the environment. And concrete this most ubiquitous pedestrian, literally building material, has great opportunities for being carbon positive. And a lot of that intersects with a broad category of technologies that spreads across many different sectors called carbon capture, utilization, and storage. And concrete has a really interesting potential here because there's many different ways in which you can take CO2 that's either sourced from industrial point sources or ultimately from the air through technologies like direct air carbon capture, which you may have read about. And you can use those as components in concrete, essentially locking them away forever, unless you were to heat up that material for, to 2,000 degrees, at which point you'd have bigger problems to worry about. And the cool thing about concrete is that this CCUS really spreads across many different components that make up concrete. So it's involved potentially in cement production, in aggregate, which is about 85% of the volume or mass of concrete, that supplements or substitutions for cement called SCMs, and it can also displace the water use in concrete. So there's broad opportunities to apply carbon utilization across all the ingredients of concrete. And there's many different companies right now already, even though it's a nascent field, that are involved in all parts of that component or value chain. There's some of them that are already out and deployed, and some are at an earlier stage. So what we try to do is, while we have an R&D wing at Open Air, we're not really involved in sort of research development directly in concrete. We're more involved in the policy side, advocating for policies at the state and local level that can help create a market or interest in those types of solutions. And we started here in New York. We have members now in 15 different states. I'm based in Costa Rica. I forgot to mention that. I'm from Albany, but a long native of New York, and now multiple countries. And our first policy that we really kicked off because we saw an opportunity was in New York State, and that was to introduce legislation that would create basically a low carbon standard for the state's procurement of concrete. And the public sector purchases and uses about 40% of all concrete, actually. You can think of highways and large-scale infrastructure that are usually public investments. And states are usually within their state the single largest purchaser of concrete. So that means that what they do and what decisions they make around concrete procurement can have really big impacts on the market in general, creating a market for some of these new solutions. And that's what the Low Embodied Carbon Concrete Leadership Act, or LECCLA, is really designed to try to catalyze or spur. And it draws on some of the elements of different policies in California and Oregon and Vancouver and Rotterdam. Around the world, this has become a sort of a bigger and bigger thing. And we were lucky to sort of sample from those policies to design this bill. But it has a unique feature, which we call climate competition. And the idea there is that the global warming potential, or the quantitative measure of your carbon footprint of the concrete, becomes a factor in how competitive your concrete is for state business. And so GWP, global warming potential, is one of the pieces of data that's quantified in environmental product declarations. Essentially, these nutrition labels for life cycle analysis for products. And so what happens with LECCLA is that you have, based on how your GWP is when you submit them for bid, if you have a really good GWP, that's going to reduce the cost of your bid. So it's going to make you look artificially cheaper. It's going to give you a price discount. So it directly ties the adoption of low carbon options to your competitiveness, which is sort of an exciting feature of it. And we were really happy and honored to have the support for this, not only of Passive House Alliance Hudson Valley and NRDC and many of the sort of marquee environmental organizations, but also a lot of the real New York-centered and Hudson Valley-centered organizations, and that list keeps growing. We just added AIA National to our list of supporters. We have the bill introduced in New York, but it sort of caught a lot of interest. We now have a bill tomorrow that's being introduced in New Jersey, the same bill, and then we have activists in Virginia, Wisconsin, Illinois that are also working and quite close to getting introduced. And we now have a confirmed interest from a Congress member in California who wants to introduce it as federal legislation. So it started to really sort of spread out and become a thing. But local government is incredibly important too, and that has to do with the sort of the unique way in which concrete is made. So we're really active on that front as well. Local governments, particularly when you look at the ones that have really stood up and designated in sort of embraced, opportunities to reduce carbon in their own communities through, like, for instance, the Climate Smart Communities program here in New York State, which you see mapped. They can really be at the vanguard of really pushing low carbon concrete here in New York and in the region. And a lot of that has to do with just the way concrete is made. Concrete is a material that is usually made in just local plants. You really can't go beyond 50 miles before it dries out. So concrete plants, all 170 to 180 of them throughout the state, are just right there in our midst. They're part of our community. So that means that the choices of local governments can start to educate and create demand at the plant level. And so that's through how they decide to specify the concrete that they do for their sidewalks and roads and buildings and infrastructure projects. And then ultimately also they have influence over their own local building codes. And so there's a lot of innovation that's happening around adding low embodied carbon concrete to building codes as a requirement or as an incentive. The effort for this was really led by the county of MARIN in Northern California in the Bay Area, but there's other places as well that are either adopting the MARIN County Building Code or creating their own standards. One of them is just right here in the Hudson Valley, in the lower Hudson Valley in Westchester. Hastings on Hudson has worked really closely with the Open Air Collective, and we have volunteers based in that community that have said, let's really make this part of our portfolio of climate impact. And we've been really excited to see what's happened in a very short period of time. It started off with a resolution that they passed. This was just a statement of principles that the Village of Hastings on Hudson is going to look at low carbon options for all of its construction projects that involve concrete. That was passed in May of this year. And they wasted no time in converting that into actual practice. Just a month later, they started the procurement for a retaining wall right very close to the mayor's house, which was ultimately poured in October of 2020. That used a mix of slag. So it was about a 20% reduction in GWP. They're currently doing the same thing with a group of communities, the river towns in Westchester, for a collective curbing project. And they're also already have started to make modifications to their building code where they're incentivizing the use of low carbon concrete. And that's under review right now. And what's really exciting, and this is what I want to close with, is their next big project that they have a bond for already that'll happen in the first or second quarter of next year is a sidewalk project. And we look at this as an opportunity for communities all over the region, state, country, and ultimately world to really sort of focus on, because sidewalks have a very, I think, sort of special opportunity to elevate awareness and practice in low carbon concrete. Sidewalks are awesome because they're a universal form of civic infrastructure. Every local government is familiar with them. They're relatively simple. They don't involve many different types of mixes. So that means that many different types of people can converge on them and understand what we're all sort of talking about. They happen very frequently. In any county, there's going to be 10 to 15 sidewalk projects that are happening. They're small, so they're good for experimentation and dabbling, and they're low risk. They're not going to fall on your head if something went terribly wrong. So they're a good place to sort of start as sort of a learning square one around low carbon concrete. And what's cool is that many of the things that you learn doing a sidewalk project can actually then translate into more sophisticated, complex projects. So again, they're a good starting point for learning. And what's also really cool is that because they're sort of common, you can get a lot of different communities sort of focusing on it together and potentially procuring ingredients together. So it allows for a sort of an aggregation type of effects, which are exciting. And so here we sort of took our cues when we talked to Hastings. You know, there's other places that really led on this. Portland, Oregon has been way out ahead in terms of local governments on low carbon concrete. And they started with a sidewalk project, mostly for the reasons that I just mentioned. And so what we're going to do in winter and spring, and we've been working really over the last 6 weeks, is recruiting local governments for, is get local towns, municipalities, counties to say, in principle, we agree to experiment or use a low carbon concrete mix for an upcoming sidewalk project over the next 3 to 6 months. Our group will go out, and we have within our group many engineers and academia and practitioners within the concrete space to actually, let's develop an appropriate concrete mix that's low carbon, that doesn't really escalate costs and doesn't in any way compromise performance, that's appropriate for the Northeast with our particular environment. So we're going to develop that through essentially a hack, you know, like almost like a truly open source type of way, almost like an open source software initiative. And what we'll also do is whatever we propose there, we don't want to propose anything too exotic or crazy that can't actually be locally sourced. We're going to, our volunteers will sample the availability and how realistic it is to implement that within the communities that sign up. And then we propose it back to the communities who will review and then hopefully improve, implement for a project, and then report back to us that they've actually used it so we can map it. And then we're going to publish that mix in any future mixes that we do through similar types of exercises on our website so that anybody who's starting off with this could say, all right, I'm going to use that mix instead of a conventional mix. So to close, if anybody is interested in finding out more, I'm going to be hanging out obviously during the small groups. But a couple of call to actions that we're working on right now. If you're interested in your area, it's all about right now, the legislative session is going to start in January. If where you are, you want to help get your legislators on board as co-sponsors, we'd love to talk to you about that. And then the local level, anywhere in the world, any local government can pass the Hastings resolution. We already have about a dozen different communities looking at passing that resolution, which really kind of sets things in motion. And then also, as a very specific project, if you're interested in your community, getting your local government involved in an open source sidewalk initiative, we're going to be starting this first cohort again in January. That'll go into the spring. Would love to talk to you about that. Please, you can go to the website that we set up for this. It's called leckwork.org. There's a little form there you can fill out. I'll get in touch with you directly and we can talk. But if you're not comfortable doing that, you can always just email me at my Gmail account or check out the Open Air Collective website. And that is it. Hopefully I didn't go over. Thanks so much.
Not at all. That was perfect. Thank you, Chris. A bunch of questions did come in. I'll invite you to unmute yourself. So James Hartford had a question.
Thanks. Is it possible to get a sample text or the Hastings resolution itself to share with our communities?
I'll post it right here in the chat, the exact text.
Thank you. And then Hugo, are you still with us? And did you want to ask your question? Hugo was wondering if the language for low carbon concrete includes recommendations for diesel cement trucks to be electric. And if not, he's urging to please include anything you can to recommend electrification of transportation of cement and any associated materials. So it'd be great to see. Yeah. Yeah.
And again, I don't want to eat into the time of our next presenters. I'm eager to watch myself. I will be hanging out and go nerd out with you all day long on this stuff. That is actually a component of our state bill. In addition to GWP, which is not captured, the transportation, we do actually urge them to include the CDM, so the concrete sort of driven, or CMD. So we're hoping that there will be some methodology for actually also capturing that. That's really significant, particularly in New York City.
Cool. And then one more. It's okay to go over. I went over 3 minutes, so I was the starter of that. One more question about from Ona. I'm sorry, I'm not going to attempt your last name. If you want to unmute.
Yeah, Ona Papagiorgio.
Thank you.
Yeah, it's intimidating. I was wondering, as like, say there is a person who wants to build a home with concrete right now, and maybe the one thing weighing on them is the use of concrete because it's so high carbon generating. Is there a place for just an individual homeowner or home builder to find this in this area?
For an alternative to concrete, or for a low carbon concrete option?
Oh, a low carbon concrete.
Yeah, and again, what I'll do is I'm going to post also a presentation that we gave a few weeks ago where Professor Matt Adams at NJIT kind of laid out what that even means. You know, low embodied carbon concrete is not one thing that comes out of a low embodied carbon concrete factory. It actually has to, there's many different, it's a whole spectrum of different things. That can be as simple as specifying less cement, using SCMs that are off the shelf, using more exotic, newer, higher impact SCMs, using carbon utilization. So there's a whole bunch. So the answer is that yes, there's definitely options that can be done just based on just current practice. But then there's also more ambitious things that require some education of providers. And that's what we think local governments can kind of be on the vanguard of that. but go ahead and DM me, and I'd be happy to kind of provide you more specific resources on what are likely available here in the region.
Thank you. And just to clarify, so this is not the technology that uses CO2 to manufacture concrete. That might be part of the equation, but you're talking about a much bigger picture.
Yeah.
Okay.
We squeeze carbon out of cement, and then we have to maximize the utilization of carbon in concrete, and that's going to get us to potentially a carbon neutral or even a carbon negative material in the future. So it's all of the above.
Thank you.
All right, so let's switch gears to Lillian's presentation. Are you all set?
Thank you, Michelle, and thank you, Chris. That was really perfect foundation for what I'm talking about. I basically helping you do away with using concrete. So give me a moment and I'll share my screen. Okay, so this is the Slabless Slab, something that I am really excited about, and in part for its literal use in design and implementation from a builder's point of view, but also from a embodied carbon standpoint. But the larger reason for my excitement about it is in my title, Rethinking Assumptions. And my friend, Stephen Demetric, who is a builder in Rhode Island, was telling me about his new project, and it included this slabless slab approach to the basement. And of course, I was really excited about what he was building, but his thinking process that he worked through along with Steve Bazek, the architect on the project, where they just really tried to set aside all their assumptions about what goes into a passive house. And they built one, and they were talking about ways to bring costs down. And this was the result of that conversation. But I think it's a great example, whether you end up doing this or like it or don't like it. I just want to encourage everyone to really try to set aside your assumptions. It's always a good practice and a design exercise, but it's just more and more important as we try to move forward in reducing carbon in our work. So I feel like when we practice challenging our assumptions, we really set the stage for innovation. And I know I'm frequently encountering people who tell me on the job site, that's not the way we do things. And I'm constantly challenging that. So I was thinking back to how I felt when I learned about Passive House, and I thought it was a great, the end goal was amazing, but I was really skeptical of the means to get there. And, we all evolve. So as a preface, this was my first foray into that kind of thinking. It was a house I designed on a site that had a very high water table, and it's a raft foundation with a concrete grade beam on top of the foam insulation. BuildingLogic in general does not use foam above grade now, but this is what we were doing then. And I know that Stephanie and North River have taken this particular kind of foundation to the next level. So I'm looking forward to seeing that. But one thing that I had to endure was my civil engineer coming to the site, bringing a buddy and pointing and laughing at the project, and just being incredulous that anyone would do such a thing. And it's a very nice, comfortable home now. So I guess I don't need to go too much into the embodied carbon side of it, but basically a slabless slab does not involve concrete, and we use Advantech instead, which is an OSB product. And so in addition to lowering your embodied carbon footprint, there's a great benefit in eliminating the moisture load that a slab adds to a building as it's drying, especially a tight building. And the work can be done indoors after the structure is dried in, instead of out in the rain where you're basically building a pond. And builders can keep the work in-house. So we had one of these on deck. We'll be doing it next year. And so I'm not showing photos of our project, but my buddies all sent me photos. And these are the folks that have pioneered this work. And I've just talked a lot too about the process. So I will also share in the chat articles, interviews, and other reference material from these leading leaders. So this is a drawing of a project that Steve Demetric did in Rhode Island. It was designed by Steve Basic. Steve Basic generally does the envelope, and Steve Demetric takes it from there. And this client wanted hardwood flooring in their finished basement. And in general, that's a challenge to do because the moisture and the concrete, and they brainstormed this solution, and I visited the home myself. It's fantastic, and it's pretty simple. Basically, the preparation is just the same as you would do for your slab. You have compacted stone, it's raked level. You have your Type 9 EPS foam insulation, vapor barrier. Everything is just as you would normally do, but you just don't pour the slab. Here's the foam being installed on site. And below the gravel is your usual perimeter drain, radon, piping. And the foam is fit quite tightly. A little bit of spray foam is used in the gaps. And they check the level with a laser as well as a story pole as they're installing. Install the vapor barrier, just as we all do. But one thing I'll point out here is that the house is already built around them. Oftentimes this work, actually always, this work is done when there has not been any house built yet. So it's basically becoming a swimming pool and you're having to pump it or drain it, and it's just a nightmare. The level of quality control that's possible here is just infinitely better in terms of sealing the pipe penetrations, the posts. It's just a builder's dream as far as I can tell. Here they're laying the first layer of Advantech. It's installed with a 1/8 gap around all the perimeters. It's not fastened. This is just tapped together. It's tongue and groove. And on the left, you can see the second layer of Advantech going down. They use 1¼ screws. So the screws are fastening the 2 layers together without puncturing the vapor barrier. And the second layer is run perpendicular to the first with at least 2 joints lapping consistently. It's a lot of layout and planning here, but the cost ultimately was just a bit more than installing a slab. And the fact that they're installing hardwood flooring meant that they could just install the floor, because if they did have a slab, they would be installing sleepers and Advantech and the flooring. So this was more economical in terms of installing a wood floor over it. Oh, I just want to say, I also really like the little trusses for running the utilities through. So good. We need more of that. These are my really mediocre snapshots from when I toured the house. The house was quite beautiful. The basement was just sort of like the family room. But it felt great. The floor felt great. It felt solid, but it didn't have that hardness that wood over concrete can have. It just felt natural, felt really good. And this was built 4 years ago, I believe, or 5 years ago. So it's doing really well. The client actually had a catastrophic flood in their house a month after it was finished. There was 7 inches of water standing in this space. And after they opened the European door, which kept it all sealed up inside and it drained out, they pulled up the hardwood floor and dried everything out. And the Advantech was completely fine. They did not have to replace it, and no water had actually gotten between the layers, which is pretty impressive. This is a variation which I think may be a little bit more palatable to folks in our area. It's the same idea, but it's used with a frost-protected shallow foundation. So again, it's your same build-up and preparation, but you're just not pouring the slab. This design is by Michael Maines, who works out of Maine, and you can see again the stone, the drainage pipe, radon. Here's the EPS. And Mike did it a little differently in that he's a real numbers cruncher. So he's like, I don't need 2 layers of Advantech, and he used sleepers, 1 layer of Advantech, and then the, I believe it was a pine floor over it. And this is a frost protected shallow foundation. So again, very little concrete. And I'll just point out this foam wing here, which helps retain the heat from the earth and prevent freezing around the foundation. And that design was published in Fine Home Building. And so this is sort of the easy reader version of that drawing. You can see the parts a little bit better. The National Association of Home Builders has a pretty good revised builder's guide to frost protected shallow foundations. It's pretty detailed and lets you crunch the numbers if you don't have the American Civil Engineers guide, which is only like $40, as opposed to the NAHB's, which is free for more guidance. And yeah, it's weird giving this talk with everyone muted, because I know this is, we all assume that a building needs a slab, and obviously some people want a slab, and it's an economical kind of finished floor. And not every site is appropriate, but there are so many homes in our area with rubble stone foundations and dirt floors that have stood the test of time for, you know, quite a while. And so maybe that slab isn't always necessary. Couple takeaways that I learned from interviewing people was using a really good excavator, and I mean, frankly, that was the big one. And just really having the right material under your foam. And just as when you pour a slab, you want it level, people have found that recycled asphalt is better for compaction and getting a really tight, solid base. And especially compared to the stone we get in this area, it's not so easy to compact. And if your engineer is concerned about ground pressure, of course, key your walls into your footings like you're supposed to. You could add more pins between them if needed. And if you're still getting pushback from a code official, running an intermediary footing across the foundation will often satisfy them and give you another surface to screed your stone off of. And I've always found that showing the code official the Journal of Light Construction or Fine Home Building article, it works like a charm. If they see other people have done it and it's not like your personal wacky idea, they're usually much more amenable to something different. And I just, you know, putting this out there, there are wood skyscrapers going up now, and I didn't know this, but apparently there are permanent wood foundations commonly built in the Midwest. So who knows, maybe we can reduce the concrete even further. So thanks, and I'd love to answer questions.
Thank you, Lillian. That was great. You were like right on time. Just,
Oh my God.
literally just sent you like the 5-minute warning.
Just by sheer luck.
Yeah. Seth, did you want to ask a question? You had a question for Lillian, I saw.
Oh yeah, hey, awesome. That was great. Thanks. Hello. Let me see. I was asking. Oh, so yeah, I actually missed at first what you put down for your installation, but then I saw. I guess you're using EPS everywhere, and I just didn't know if you had looked at other options like rock wool, but then I guess that's about the same, like CO2e as EPS typically. And then I was wondering if you had messed around with anything else like expanded glass aggregate or perlite or anything else that would like drive the CO2 like a bunch down.
I am really curious to try Glavel. They are building a plant to produce it domestically. So that is something I haven't checked the R value comparison or the cost comparison. Or the embodied carbon. You know, it's just like we keep, you know, there's these easy chunks to shave off, but then you know, we start splitting hairs. So yeah, I'm totally, the less foam the better, but if, you know, there's a point. So I'm open. If the rock wool embodied carbon dropped, it, you know, their board material can be quite dense, so that could be an option.
Thanks.
James, you're next. Your question.
Hi, James.
Hi, how you doing, Lillian? Thank you for this. I made a couple comments, not quite so much questions, but particularly Pour-Over is a glass, expanded glass aggregate that can boost the R value pretty substantially in concrete. Lightens the weight of the concrete as well, so you're reducing the emissions from the trucks delivering it. And we've used that for our Seminary Hill Setters project. For others, that's a certified passive house that's nearly complete. And it's so we were able to actually go without the ICF forms because the added R value was actually what we needed, plus a little bit of exterior insulation.
Nice.
To where we needed.
That's great.
Simplify the build, reduce the risk to the builders because they're quite tall walls, and the chance of blowout is something they were greatly concerned with. So Pour-Over is an interesting product. Glavel is something that we're considering for a couple projects as well. The great thing about Glavel is that it doesn't float. Prior to us learning about Glavel, we're working on a project here in Village of Cold Spring that's well within the floodplain of the Hudson River. And so having all that insulation under the slab raft and lift the building was a grave concern, and because it will flood probably within the next month, who knows.
Right.
So we had to design a quite extensive and elaborate concrete weight, counterweight to hold it down. So we actually increased the amount of concrete because of that rafting problem. The gravel, if we had that in time, probably would have eliminated that. And so in another project right on the water nearby, we're considering the clay pour gravel, like insulated slab with their glass foam underneath.
Thanks, James. Thanks. I like the angle that it was lightening the weight of the truck, because ultimately transportation is one of the biggest carbon impacts of our job sites, is the trucks coming and going and the workers coming and going. I hadn't thought of that angle.
Well, thank you, Lillian.
You're
This was
welcome.
great. And I'm sure there'll be more questions for you popping up in the chat if you want to keep an eye on that and share any links or anything.
I will start linking now.
Sounds good. And so next we're going to hear from Stephanie and Chris at North River, and also after that, John, I won't get in the midst of that. So take it away, Stephanie.
Okay. Hey, everyone. Just a brief introduction. Our architectural practice has been working out of Stone Ridge in Ulster County in New York for 10 years. And we've, in the past year, formed an official construction company. So we're North River Design Build now. And what I'm going to be showing you is, and Chris will be talking about too, is our first construction of a passive house, a certified passive house for a client. I specify it like that because we built a house for my design partner, Peter Reynolds, back in 2016, where he was acting as GC. So it's sort of a unofficial capacity as construction managers then, kind of launched us on a nice growth curve in terms of our own learning, our own comfort level with passive house detailing, our real immersion in the supportive and really wonderfully collaborative community with the Passive House Alliance, involving a handful of the professionals here at this meeting, and really expanding our sense of community, and wanted to share back to the community with our version of an open walls tour. We're lacking, the really great impact and immediacy of being able to offer our construction sites to tours now during this COVID period. And I thought it's the next best thing, given the circumstances, would be to show some video and talk about what we've learned along the way as we've officially GC'd our first passive house project, and to show you some of the techniques of design, detailing, and construction that we've come up with as our kind of our go-to set of details and methods, and where we're sort of pushing the envelope and exploring some new ideas of design and how that's impacted the ease and feasibility of how we're building passive house. So I'll just start a little slideshow here by sharing. Let's see. I think this could be a better view. Let's see. I'm not sure if I can improve the view. I'm just going to go through the slides like this. Okay, so this is just an aerial axon showing the house in its relationship to an existing 1800s agricultural barn on a property in near Pine Plains, New York, in Dutchess County. there used to be a horse stable here in the position of the house, a smaller footprint, but roughly there in that orientation, and this established gravel courtyard overlooking, an open, sort of mature farm area in a pretty rural part of the county, in Dutchess County. So this house is, here's some renderings, just a quick preview of our design intention. This is putting its best face forward in as a digital rendering. We'll show some current photos at the end of the presentation. So this is a stuccoed frame construction. It's attached to the existing barn. The family of 5 with 3 young children wanted to integrate the use of the barn into their daily life, but just have the option to not have a dusty barn as their house per se, but be able to use it for a fun space, a gathering space, a flexible community space if they ever wanted to open up the site to larger groups. They do have a lot of flexibility in their planning and wanted to make this house and the development of the property expansive in its potential. So this would be the uphill entry side of the barn. It's involved a substantial restoration of the timber and the exterior cladding. And I'll just get into a look at the layout of the house, and then I have the open walls tour coming up. And at the end, Chris will talk about some of the aspects of the construction process that we've learned a lot from in this outing. So we have what we have been doing in about the last 4 years in our design practice is settling into the idea that a simple gabled barn type of structure for a new construction passive house is the least expensive way to build, and therefore offers the most access potentially to people who are seeking to build a passive house for themselves. And in other words, the least number of bells and whistles in terms of the volume and the complexity of the planning, and offering as much flexibility of interior layout so that a house could have a lifespan of 100 years, in terms of being adaptable to different patterns of use, rather than more limited and specific to the current kind of lifestyle of the people who are occupying the house. So that's been a sort of developing concept of how we are offering design of passive houses to our clients. Simple, gabled, slab on grade. I'll show you a section of that in a couple of slides. And this project offered us the opportunity to do a little bit more, and that's because the clients had an interest in some more expressive design. We were creating shading by creating some cantilevers. The connection to the barn just necessitated a level of complexity that a standalone building wouldn't have. So on the first level, you have an open living space in 2/3 of the footprint of the house, and then an entry mudroom office area in the rest of the footprint. And then there's a walkable passage through and underneath the bridge that connects to the barn on the second level. We really like to facilitate outdoor living, and they were interested in this as well. So there's a substantial deep porch actually on both sides. The orientation of the house is north-south along its roof ridge axis. So it's not turning its flank to the south, which is what we've typically been doing for solar orientation in our passive houses. But even so, with the sun angle, being east to west, kind of arc around the southern side of the house. John Mosher, who's going to talk briefly after this, was our WUFI modeler and consultant, helped us find that that wasn't the orientation of this building to the south was not a limiting factor in meeting the criteria for certification. So it's nice to know that there's flexibility, and we're able to work with the, as I mentioned at the beginning, the sort of existing site plan of this house occupying a side of an existing courtyard. So on the second level, there are 5 bedrooms, a playroom for the kids, and a connection to the barn. It's a pretty simple single-loaded corridor, and just large tilt-turn windows along the flanks of the house. In this area, in the sunroom, we have more substantial glazing. It was just a great design opportunity to have this be a really glassy kind of space. We had some mechanical challenges there in managing overheating, but managed to keep the second level on a single mechanical zone by making operable windows on both sides and allowing for just natural air ventilation to offset the some of the overheating that Kramer, our engineering consultant, was finding in this space. Here's overall typical building section cut. This would be, our sort of standard partie for our projects. We have a haunched slab on grade. It has that skirt that Lillian was talking about or showing you in her project, which is part of the frost-protected shallow foundation system. We use EPS insulation and under the slab and up the edges of the footing. And other than that, it's a standard 2x6 wall construction. There's manufactured roof trusses and continuous exterior insulation, rigid insulation. The material that we have been using for most of our projects is polyiso cyanurate foam insulation. We've been able to use fiber insulation, wood fiber insulation on one project, but have found it to be cost prohibitive under budget pressure in most of our other projects compared to polyiso. I know that the use of foam in projects, has other considerations than cost, but the budget is a large driver in these decisions that we have to confront, and aren't always able to sort of hold the line of trying to go foam free, although it's on our minds and it's a goal. So this is the 5 principles of passive house. I think we're probably all familiar with what they are. I don't have to dwell on them, but we do have balanced ventilation with energy recovery with a Zender Q450 in the house. Optimized solar orientation. Like I said, it's not presenting a long flank to the south, but we're hitting all of our targets with the wintertime solar gains and shading factors for summertime cooling loads. So I would say that it's optimized, even though it's a little unusual. Airtight construction is following this red dash line around the perimeter. It's taped zip sheathing. We try to be economical in our material choices, and it works for us. And we've been happy with generally with the quality of work that we get out of our framers in terms of them being able to tape and manage that airtight assembly for us. But Chris can tell you a little bit more about some challenges there. And then underneath the slab, we have a poly membrane that comes up and is tied into the zip sheathing to complete the airtight construction. This is just a quick bridge section, so you can see that this is the soffit condition that we've created by having this the floor open to ambient air at the second floor level here. And then we have a couple of cantilever conditions that Chris can talk about again at the end. And we're just wrapping our typical polyiso assembly around the underside. So we're sort of treating the soffit as a wall in terms of its materials and assembly detailing. And then a little more detail. I just have a lag on getting to the next slide. If you give me a second. Oh, it's the pinwheel of death. Okay. Sorry for the delay. I'm just not able to advance this slide right now. Okay. This is just a slide showing the assembly components that I was just describing. We have loose cellulose up in the attic, and that's up to 22 inches for R80. We have our 2 layers of insulation over the framing, which has dense packed cellulose in it, and the walls are R44, R43, 44, and then underneath the slab, 8 inches of EPS insulation for R38. The bridge section is the same, and as I said, the soffit condition just becomes a sort of wall turned horizontally in terms of its component parts. This is the first video walkthrough, and I'm just going to talk over it as we go through. This is the first floor. The mechanical contractors were working on the ductwork installation. We have 2 points of supply, and that's the kitchen. And then looking down this room, there's another heat pump supply register that they're working on for the living area. We're able to use a slot diffuser for these spaces, which worked well for our ceiling design. And we're looking now into the side of the mechanical room, which opens directly to the exterior for access to the equipment. And that was the Zender unit mounted on the wall. We have ductwork from 2 air handlers. Like I said, there were 2 zones. And here are those floor trusses that Lillian was talking about. They've been really instrumental in being able to run all of those services and systems. They were packed absolutely full by the time all the trades were done. So I can't imagine, and we've been able to work with TJI cut limitations if we'd gone with that kind of floor system. Let's see. The next video takes you up the stairs, and you can see the rough-ins for the from the heat pumps here coming up to high wall positions. I'll note, just keep an eye on the ceiling. We have quite a number of wire penetrations through this airtight zip ceiling, which proved to be troublesome as we're trying to hit our blower door test target. And we had to do a number of stressful spot repair efforts to get within the range that we needed to. This is coming back to the rear bedroom and turning the corner to the bridge, which goes to the barn. And into that, turning back and looking again to the north. The next 3 videos are short, they're brief. They just, in an open walls tour, we were lower door testing around that same time period. We had mechanical systems substantially in, and wiring and plumbing rough-ins substantially complete. So, that's the is pre-installation, so you can see all the framing and the structure and all the services and parts of the building. So it's interesting mechanically to see the systems and how they're distributed throughout the house. I'm just pausing on a few of those mechanical components. This is the Zender Console Air Q450 in the mechanical room. Pretty compact installation, going to getting its large ducts to the exterior for the intake and the exhaust, and then distributing all the spaghetti corrugated plastic ductwork through the house for the supplies and returns back into the unit. This next little clip is one of the air handlers. We're standing in the powder room on the first floor looking overhead. We had tall ceilings in this house, enough so that we could put a slim heat pump above the ceiling and have ductwork running underneath it and still have a reasonable ceiling height in there. And one of the challenges of Passive House for us has been to solve for the domestic hot water, which requires in order to meet the efficiency targets, so far we really can only use a heat pump water heater, which need either a lot of space that they're located in because they rely on the air temperature of the room space for the energy transfer, or that you need to provide a ducted intake and exhaust in order to use the air of the house itself. And so this right here is the exhaust component of the heat pump water heater, and it was a bit of a challenge to integrate that into the design of the house, but we managed to find an understair spot that worked well for us in the end. That's a radon pipe going up, so we're still venting radon in our passive houses from underneath the slab. I'm going to turn this over to Chris. He has a few comments about the construction process to share.
Okay, can you guys hear me all right? Great. Yeah, so from the construction side, one piece that was really different about this process since the last time we did a design build is the schedule on this project. So just to put it into perspective a little bit, I mean, it's a roughly 3,200 square foot house, and we didn't put a shovel in the ground until June 1st, and we're looking at substantial completion by the end of the month, this month. So it's a 7-month turnaround for the house, the barn, and the interconnection between the two, and everything else associated, which is, as all of you know, a really tight schedule without it being a certified passive house, and just made that much more demanding by the fact that it is a passive house. So the way that, I mean, that was sort of the biggest lesson I think coming out of this is just the demands that come up in scheduling and sequencing when you have those things in parallel, wanting to be certified and wanting to meet a demanding schedule like that. So the first thing that was an issue that we found was in framing. As we sequenced, we got our framers on site and they had started to work, but because of some shipping delays, we didn't have trusses before, we didn't have trusses the day we wanted them. They were going to come a day later and they wanted to keep moving. So they began framing second floor interior walls before the roof trusses went up. And the reason why that's an issue is because of the detail Stephanie spoke about before. On that picture on the right, you can see it's hard to see, but there's a little bit of the bottom side of zip along the wall plate because we bring our green face of zip up the wall and then over the top of the wall plate and tape it up over that corner and then set our truss on top. And then we can come in from below and put the zip to the bottom of the truss and tape it. It's a lot better to do that before the interior walls go in, but because of sequencing, we didn't have a chance to do that. And we ended up with a process where they're taping after the walls had gone in. So anywhere where a tape seam crosses the wall, we had to go up to the top side into the attic and tape over it from the top. And in many cases it worked, but in many cases it failed. And we noticed that in the blower door, and it became this sort of running loop of chasing ourselves to find those little leaks in every little place where it happened in that air barrier as a consequence of this. So that was one lesson learned, and it became kind of a typing nightmare and a bit of a, you know, overuse of Sega tape to get ourselves over that hurdle. And the second part of this was that there's this weird circle of scheduling that needs to happen, which is that you need your insulation before we can close in the soffits. As you see on the picture on the left, that's exterior soffit, but it's floor system, and you have to insulate that before you can put the rest of the zip on. But you need your soffits closed before you can do your blower door test because it's your air barrier, but you can't close them until the insulation goes in. So there's this like strange cycle that we found ourselves in where we had to put the zip on before we could insulate. And it wasn't, you know, we eventually decided to go through with some holes from above in the Advantech from above and blow the insulation into each bay from there. But that was a big learning curve because it sort of, we all understood, you know, the need for that a little late, and we were going to solve by putting plastic in place. Like, I don't know, maybe some of you have done that for blower door on a door or a window. You just use plastic temporarily and then put the window in. But it was too big of an opening for the soffits, and it didn't work. It was not okay. So that was a scheduling issue that we ran into that, you know, I think is just the consequence of such a tight, demanding schedule like that. The other demand that we found was in some of the design considerations. So on this project in particular, we had a barn, and I mentioned before, getting the framers there on site, we had them start on the barn just to get them on our dance card and have them start working. So to be able to even frame the house into the barn like we have it, we had to first remove the wall of the barn, shore it, remove it, and pour a new footing that would ultimately be the support for the barn and this new bridge. And then once this new building bridged into the barn, we were only, you know, to minimize thermal bridging, we only had 2 points of connection. So we had 2 small points where that bridge would connect into the barn. We had to leave enough room around it to wrap our blanket of insulation around the exterior. And explaining that to framers at the front end of the project that we're going to slip insulation between an old antique barn and this new building was a challenge. But you know, ultimately the detail worked out. We only had to move a beam once and a post twice, and here we are. So you see the picture on the right. We now have that stucco piece of the building popping through the barn, and ultimately, you know, got what we needed on it. But I think the summary of that is that having that demanding schedule was caused a lot of headaches. But in retrospect, I think that unless anybody else has another way, and I'm happy to hear it, I think if we hadn't kept that demanding schedule in the front of our minds all along and had sort of conceded some of those things in scheduling them differently, we wouldn't have been able to meet a 7-month or even an 8-month for that matter. And keeping the pressure on at every point is, I think, the only way we were able to get to this place, which is where we are now in these photos. You know, the upper right and the far left being the most recent, just not showing the other side of the building. So we're at the point now where we're, you know, wrapping up some trim on the exterior. You see we have a sample trim on the upper right-hand photo. The second window in is the mock-up. And those window trims are now built and ready. Yep, thank you. And the interior is sheetrocked and getting taped as we speak. So yeah, it caused a ton of stress to have this schedule, but at the end of the day, I'm pretty excited that we were able to get this much building to this level built under that time frame. So it's exciting.
Agreed, Chris. Thanks so much.
Sure.
Just a quick note, we have solar panels going on the barn roof and then on the western roof, the other side of the house roof from this view. I guess this one at the entry side. It's a 16 kW array. About 11 kW would be net zero for the electrical needs of the house. But we oversized it for future EV charging and load spikes, and we're able to fit those panels on the roof. So looking forward to sharing the finished product with you and at some point. There's some questions. Should I just go through those, Michelle?
Yeah, I thought John was also going to speak on behalf of your
Oh.
project. Maybe I was wrong.
Sorry, John.
No, totally fine. Do we have time? I'm glad to.
You know, it depends on how long your update is for Phius Plus, and
I think
yeah.
I can wrap up with some quick comments on this one.
Mhm.
You know, I was just going to show some screenshots of my Woofy model for this project, which would be fun but technical. Just one observation, just to kind of, you know, obviously Stephanie and Chris have been talking about managing the construction through all this, but I just really wanted to commend them because from managing the consultants, so myself and Kramer, I've noticed a really kind of streamlined process with North River that I think is really critical to just point out. And that's why I want to make that point to everyone here. Because being able to integrate that feedback loop with the energy model and also the mechanical engineer, both in design, which was a short period, and then also through construction, was really impressive. So, you know, Chris saying to get this building built in about 7 months, you know, and then adding the passive house element, you know, to get Tony Lasanti out there on a specific day is not an easy task. You know, to get feedback from Kramer, you know, can sometimes take a little bit more time. So, you know, there's both the management on the construction side of things that Stephanie and Chris have been doing really well, but they've also managed all the consultants really well, which I think is definitely adding to the increased timeline, or, you know, shorter timeline on the project. So
Thanks, John.
you can do a follow-up one day with the Woofy results.
Okay. Michelle, is there time to go through any of these questions?
yes, we can take a couple of minutes. And there's a question on stucco about synthetic or not. Yeah, from Seth.
I tried to answer some of those just in the chat quickly, but
Great.
yeah, it's synthetic over dens, and that's mounted over furring strips, and it weeps at the bottom. Yeah, the weep is ugly. It's hard to hide. It's the only thing I'd say about that.
Yeah, it's not a sort of proprietary system like a stow back drained. It's more sort of a site built with ventilation and drainage behind. Yeah, Chris, you did answer the on the barn. It's the material is Eastern white pine with an iron oxide finish.
There's a cost question. I don't know if that one got answered.
This is not a cheap building. with the barn, I'm not sure if I can back it out without the barn in it, but I think it was about, yeah, probably about $500 a square foot. Well, eye-popping. Lots of specialty interior finishes. Millwork, actually, is a large millwork budget included in that. And
yeah, the client opted for, in many cases, opted for millwork in place of furniture. You know, so even like there's no dressers in the primary bedroom. There's no custom bed that's built in. So like that stuff drives the cost. And also just what you're not seeing in the pictures is that the first floor finish, the entire ceiling of the first floor is white oak strips that match what you have underneath the exterior. So there's a sea of white oak throughout the project, which isn't cheap.
Sounds incredible.
It's beautiful.
The slab turned out amazing. We have been able to power trowel for a really great finish on our projects. Only need to be sealed and then they're a workable surface for interiors. In this case, there was some cracking and needing to make some repairs, and so it ended up being ground down. So it turned into almost a more sort of studio finish with areas of different aggregation coming to the surface. There's some variation in texture and color that, you know, brought a lot of life to it. So kind of a happy circumstance, just required because of some issues with the pour.
I think we're going to shift gears if you want to keep answering questions in the chat, Stephanie and Chris, and let John give us the 2021 update.
Great.
Sure.
Yeah, thank you for sharing that, Chris and Stephanie. It's really good to see that project. It's very well done. So I'm going to try and keep this brief so we can get into the networking session, but there's been a lot of discussion within Phius and Passive House Alliance about the Phius Plus 2021 update. Maybe some of you guys remember we had a meeting in NIAC a couple of years ago when they released 2018. And I think it's safe to say that 2018 had some pretty significant changes. As everyone knows, Phius updates their protocols every 3 years. So they're now rolling out the 2021 protocol. The changes are a little bit different than what we saw in 2018. And although there are resources available, you can look on YouTube, and Graham and Lisa and James from Phius actually explain this in more detail. I wanted to give a summary because with so many local practitioners in the area, I think this can really have a profound impact on the amount of passive houses that we're able to roll out in the area. So I'm going to kind of talk about this in 3 particular themes. The first theme is that it's easier to use. So the big part of that is they are starting to move towards a prescriptive path model for simple single-family and single-family attached projects. So essentially what that does is allow you to follow a series of prescriptive requirements per climate zone, and then not do a woofy energy model. So it's a lot like other certification bodies like LEED, where you can do a prescriptive, or you can do a kind of custom submission. You'll have the option to do either for single family homes now. And again, that cuts out the need of the woofy passive energy model. Although you still are required to be a CPHC to actually submit the project. The other big change here is that there's no longer a requirement for renewables. It's unclear exactly how that will play out, but that primary energy target, what we saw in 2018 was that the heating and cooling requirements were kind of eased up or relaxed in a way that made it easier, whereas the primary energy was more difficult. So they're making effort to ease up the requirements on the primary energy. So those are the big things as far as what's easy to use. There is restrictions as to what kind of projects or what characteristics of those projects can be used under the prescriptive path. So we have a quick general scope here: no jetted tubs or indoor pools, no natural draft fireplaces, no fossil fuel combustion equipment in the house. Those are principles that we generally follow to begin with, but just to kind of reiterate, it's all climate dependent. And building dependent. So essentially there would be a checklist, just like what the HERS raters are tending to use right now, where we can go through specific elements of each of the projects and make sure that it follows those elements relative to our climate specific requirements, and submit that along with our documentation to Phius instead of submitting our woofy energy model. This is a quick, just kind of organization path. There are still going to be many projects that will require a woofy energy model, including multifamily and commercial. But again, if you meet the very specific requirements for the single family home, then you can follow this prescriptive path. The second theme that we're talking about here is better design guidance. So they're kind of refining the variables a little bit more in order to allow you to take advantage of the benefits of, you know, a more dense floor plate or a more efficient building envelope. So again, they are looking at much smaller units, all the way down to 200 square feet of floor area. In 2015 and 2018, that was less accurate, so we experienced something called the small building penalty. They were able to further refine that for 2021. There's the inclusion of a dwelling unit density in the space conditioning criteria. So AKA when we go to determine our targets on the Phius calculator, we're able to put our dwelling unit density in and basically get a boost for doing that. And they're now rolling out a non-residential QA protocol. So before, when we worked on commercial projects, we were essentially just basing it off of the residential protocol, but now they have a specific protocol for non-residential projects. Essentially, the workflow will be the same. In order, we're designing our building in order to establish our baseline targets for certification. We'll go and we'll find our Phius 2021 calculator instead. We can see there's just a little bit more information to further kind of fine tune what our space conditioning criteria will be. And we see the same criteria on the bottom: annual heating demand, annual cooling demand, peak heating, and peak cooling. Those are kind of the core targets that we need to hit. And then you can see they've separated out the source energy criteria. We have that same 3,224 kilowatt hours per person for the Phius Plus 2021, but then they're also putting more emphasis on the Phius Plus Source Zero certification, which we have seen before, but now they're kind of rolling that into a standard package. So building off of that idea of getting to Source Zero for our projects is that the purpose of the 2021 is more immediacy towards satisfying our climate crisis response. So putting more emphasis on reducing our total primary energy, making Passive House more accessible so that we can roll that out in a more a massive way than we are right now, especially for single family. There is now a requirement for electrical vehicle ready. And again, they're shifting that focus from the 2021 core program to the Source Zero, kind of trying to make that the standard to get down to a Source Zero primary energy. So, you know, that pretty much sums it up. They are within kind of fine-tuning the targets. We're looking at a state-by-state electricity mix instead of a national average, which should help in states where we have more clean grids. And then I'll just leave you off when a few minutes over with just the timeline of the rollout. The public comment period unfortunately just ended, but we do have the full release starting January 1st. With that full release, we will be required to use the 2021 protocol. So we can either kind of stick the same path where we're using our energy model. We can try out the prescriptive path without an energy model. But either way, check out phius.org for further clarification and direction on the new certification criteria.
Thanks, John.
Yeah.
That was great. And Tony had a clarification that Phius 2021 prescriptive path is for Phius core only, not for Source Zero.
Great. Thank you, Tony.
Yep. And so for Source Zero, energy modeling would be required. And then I know we're a little bit over, but I think I'm going to just steal some time away from our conclusion instead of not allowing questions here. So if anyone has questions for John, you know, please ask them.
I will also just say that I'm just echoing what Graham and Lisa and James have already said about 2021. They're really the experts. But I just found it so valuable with this prescriptive path that I wanted to make sure that our Hudson Valley community was getting a preview of it.
Thank you. That's great. It doesn't seem like there's any follow-up questions right now. So I think with that, we can, maybe one just popped up. Tony has another clarification. Tony, you want to just chime right in? Oh, he's telling raters and verifiers will be having their annual webinar in January. So if you're a rater or verifier, tune into that in January. So I think Lauren is going to beam us all into our separate little breakout groups so that we can talk further.